Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about ideal gas law proportions, and I'm really just going to try to show you how to set up proportions using that ideal gas law. So let's go ahead and get into our first problem. Let's say I have a container that has a pressure of 1.21 atms. The temperature is 300 K. And what I'm going to do is I'm going to heat this container up, okay? So it's the same container, same volume, same size. And when I heat it up, I'm going to heat it up to a temperature of 365 K. And my question is, I want to know what is the pressure when I heat it up to 365 K. So the way you handle proportions in chemistry is we're always going to start with PV equals nRT. We're going to put the constants on one side and all the variables on the other side. So let's go ahead and do that. PV equals nRT, and I'm going to circle the things that are constant. Okay, well, number one, I know that the gas constant never changes. It's always equal to 0.08206. The other thing that's not changing is the size of the container, so the volume is constant. Okay, and since it's sealed, we know that the moles are not leaving or new moles are not coming in. This is simply a proportion between pressure and temperature. So I'm going to put all the constants on one side and all the variables on the other side. So I'm going to bring the T over here. Okay, so it's going to be P divided by T. And I'm going to bring the V to the other side so that I have all of my constants on one side. Okay, so everything in the circle are the constants. Okay, if these things don't change, okay, then and it's always equal to P divided by T, well, the first situation is going to be equal to the second situation. So we get this proportion that is P1 over T1 is equal to P2 over T2. Okay, and what we're solving for here is P2. So we're going to bring this guy up, T2, and then we're going to plug everything in. So temperature 2 is 365 K. Pressure 1 is 1.21 atm, and T1 is 300 K. And as you can see, the Kelvin cancels out. 365 times 1.21 divided by 300 is going to give us a pressure for P2 as 1.47 atm. And I got to ask myself, does that make sense? If I heat a gas up, it'll start moving faster. And if it starts moving faster, there's going to be more hits on the container wall, which means that that would be an increase in pressure. So my proportion kind of makes sense. Okay, let's do one more. Okay, we're going to do this one with pressure and volume. Okay, we're going to say that P1 is equal to 1.2 atm. V1 is going to be equal to 3.0 liters. P2 is going to be equal to 2.4 atm. And what we're going to try to solve for is V2. That's what I want to figure out. So once again, I'm going to start with PV equals nRT. Okay, so PV equals nRT. And I'm going to put everything that varies on one side and everything that is constant on the other side. Okay, what looks like it's the pressure and the volume that are changing. Okay, it doesn't say anything about the moles, doesn't say anything about R, doesn't say anything about T. So these are my constants. They're not changing. Okay, so I'm just going to set this up as P1V1 is equal to P2V2. So in this case, we're just multiplying the two. Whereas in this case, we didn't do that. Remember, that was kind of like the division, okay? And that's why it's so important that we always put the variables on one side and the constants on the other side. Because sometimes you're ending up dividing, and then sometimes you end up multiplying, okay? So let's kind of finish this problem. P1 is 1.21 atm. V1 is 3.0 liters, okay? P2 is 2.4 atm, and then we're actually trying to solve for V2. So what we're going to do is we're going to divide by 2.4 atms on both sides. And then the ATMs cancel out. 1.2 times 3 divided by 2.4 is going to give me an answer of 1.5 liters. Okay, and then we got to ask ourselves, does this make sense? As the pressure goes up, okay, the volume should go down. And as you can see, I doubled the pressure, so my volume is going to go down by a half, and that makes a lot of sense. If this video helped you understand how to set up proportions, please give it a like and subscribe, and even add a comment, because that really helps to get this YouTube algorithm out to other students that might be interested in learning chemistry.